Okay, today we're going to talk about section 15.2, ionic bonds. Now, we have already covered a lot about ionic bonds, so most of this is going to be a review. Now, the first thing that you have to be familiar with is what an ionic bond is. So remember, is in terms of characteristics of a bond. We know that they are coming from a metal and a nonmetal, or cation and an anion. Now we've been doing dot structures, and one of the things, again, that is a characteristic of an ionic bond is that you're going to see a transfer of electrons. So really this is the first main characteristic of an ionic bond. So if we look at our dot structures, that's going to help us to show it a little bit better. So let's look at making salts, table salt from sodium and from chlorine. Sodium has one valence electron, so it has one dot. Chlorine is in group 7A, so it has 7 valence electrons. And you can see that sodium's got 1, chlorine's got 7, chlorine needs 1, sodium can give that away. Now, in the last section, you saw that this was 1s2, 2s2, 2p6, 3s1. And then chlorine, we can do a shortcut for that one. Chlorine, we'll do neon, and then 3s1, 3p5. So we can see that this outer shell this is our valence electrons, that's where the dot is coming from. And here's our valence electrons, that's where the dots are coming from there. Oops, that should be a 2, sorry. All right, so what's going to happen is we are going to see a transfer of electrons. So this electron right here is going to go there. That gives us our Na+. Okay, so that's the ionic dot structure. And then we get Cl. Now instead of having 7, we now have 8 with its minus. Okay. Then since these are oppositely charged, they're going to attract. This is what we call the electrostatic attraction. Between opposite ions, oppositely charged ions. This is your second characteristic of an ionic bond. Again, you can find these characteristics written on your target 5.5D/E for ionic compounds. Now if we take a closer look at what happened here, when this lost, it became 1s2, 2s2, 2p6, which is now full, and this became Ne, 3s2, 3p6, so which is also full. That's why they like to transfer. Okay. We also talked about bonding capacities. This has one lone electron, this has one lone electron. They both have a bonding capacity of 1. Now this can get a little more, just a little more complicated, not much. Let's say we're going to go with magnesium with chlorine instead. So again, chlorine is still group 7A, still going to have 7 valence electrons, but magnesium is in group 2A. So it has 2 valence electrons. So this has a bonding capacity of 1. This has a bonding capacity of 2. It works a little bit different. Metals still want to lose, nonmetals want to gain. Now, here, this chlorine is satisfied. It has its 8. It's going to be full, like we saw in the earlier example. However, magnesium has not lost both of its electrons, so it is not full yet. So what it needs to do is lose another one, which means chlorine is the magnesium is going to need another chlorine atom so it can bond there. Now, what this shows us is that our ratio is going to be different. Our formula is going to be MgCl2 instead. Where up here, our formula was simply NaCl, 1 each. A +1 and a -1 add up to 0. Here, we can predict that it's going to be 2. So we can use our dot structures in order to predict formulas. We could do this again with aluminum. Aluminum has 3 electrons. We do it with chlorine again. Chlorine still needs 1. Well, 1 can go there, but that's not enough. So we bring in another chlorine. Okay, another 1 moves there, but that's not enough. So we bring in another chlorine. And that gives us that. So we can predict that our formula is going to be AlCl3. Okay. This ended up being Al3 plus, and then we had 3 Cl minuses, which would give us that here. This was Mg2 plus, and then we had 2 chlorines, each with a negative charge, which then gave us our MgCl2. Okay. So we can predict how they're going to bond. That is part of your target 5.5D/E. It says you can predict which pairs of elements are likely to form ionic compounds. Again, remember you need a metal and a nonmetal, or a cation and an anion. And the net charge must be 0. Okay? Net charge of 0. Another characteristic of your ionic bond. The last thing that you need to know for this are the characteristics of the ionic compound. That's just a little bit different, and that is a repeat. We have had that before. So properties or characteristics, we should say, it's up to you how you want to remember it. Properties / characteristics of ionic compounds. Okay, compounds. This is different than the bond. So this means, what does the compound itself look like? Again, they have crystalline structures. We learned that before. They will form crystals when the oppositely charged ions come together. Crystalline structures. That's a T there. Okay, crystalline structures. We learned that they have very high melting points. Okay, high melting points. Remember, greater than 300 degrees Celsius. We also learned that they can conduct electricity, but remember, not as a solid, only when melted or dissolved. So we had talked about that before when we were comparing molecular compounds with ionic compounds. Now, one last thing, for if you were to get the 10th point on the quiz, explain the electrical conductivity. Again, if we were to look at a solid, your solid would be a crystal structure like this. You'd have plus, minus, plus, minus, plus, minus, opposite charges lining up, because opposites attract. Oops, that's a minus. Okay? And they're stuck like that. They vibrate in place. They're not free to move. However, if you take this and you melt it, you're going to see these moving around like a liquid. Okay? They flow. And now your charges are all over. Or you dissolve. If you dissolve it, what you're going to get is a positive surrounded by water. Okay. So your water will surround the positive. There's my water. And water will also surround the negative, but it surrounds it in a different way. Okay, they're kind of like opposites. Okay. But, again, they can flow. And that's the key here. When you melt it or you dissolve it, your ions can flow. So why can they dissolve, or why can they conduct electricity when melted or dissolved? Because the ions are free to move. That allows them to carry the electricity, to carry a current. All right, and that's section 15.2.